Hello, everyone. Welcome to today's webinar. I'm Melissa Romero, Forensic Science Consultant in C&EN Media Group. I will be moderating today's event. This webinar is titled Best Practices for Limiting Hazardous Solvent Exposure with SafetyCaps and Waste Containment for HPLC and UHPLC Systems. It is sponsored today by MacMod Analytical. C&EN works with sponsors to identify topics of interest and value to C&EN's audience and consistent with C&EN's mission to provide news and analysis of the chemistry enterprise in a timely, accurate, and balanced fashion. During the webinar, you can adjust the size of the slides on your screen by grabbing the lower right corner with your mouse. If you need technical assistance, please look at the Help widget at the bottom of the screen or type your query into the Q&A box. If you are disconnected during the webcast at any time, please log in again according to the instructions you received earlier. You're encouraged to contribute to the success of this webinar by asking questions at any time during the presentation through the Q&A box on your screen. The questions will be answered at the end of the presentation, and as your moderator, I will be posing as many as time permits. Please note that C&EN does not endorse any company, products, or services that may be mentioned in the webinars. Each webinar will be archived at C&EN online after the live webcast. The presentation today is sponsored by MacMod Analytical, whose mission statement can be summed up into one simple phrase, smarter chromatography. But just what does smarter chromatography mean? It means that when they make a recommendation to you about an HPLC or UHPLC product, it is to partner with you to offer innovative solutions to your complex problems. They use an advanced state-of-the-art analytical software to match their product portfolio with your separation needs. They leverage their 30-plus years of experience in the LC column business, their technical expertise and manufacturing network to help you solve your toughest application problems. They provide up-to-date and accurate technical catalogs and reports from industry-leading separation scientists to keep you informed of new technologies. During the presentation today, we will be hearing from Edward Faden, Northeast Regional Sales Manager at MacMod. His territory includes the states of Pennsylvania, New Jersey, New York, Massachusetts, Delaware, and Connecticut. He received his Bachelor of Science in Chemistry at the University of Pittsburgh in 2013. Since then, he has served as a trusted chromatography partner for customers for 7 years. He has experience working with major pharmaceutical, biopharmaceutical, industrial chemical, and environmental companies to improve their workflow and provide innovative solutions to their challenging chromatography-related problems. Edward has been acknowledged on several publications and posters and has frequently been counted on to provide industry-leading presentations at conferences, meetings, and on-site customer facilities. Now, let's get started. I will turn it over to Edward.
All right. Thank you, Melissa, for that gracious introduction, and thank you to C&EN for broadcasting this webinar. Today, I'll be talking about a very important problem that many people who work in the lab today might be overlooking. That problem is solvent evaporation exposure from waste containers and solvent reservoirs within the HPLC and UHPLC instruments. We aim to solve that problem by providing a brand new and not very novel product line called SafetyCaps for your solvent reservoirs and safety waste caps for your waste containers. As mentioned, our seminar is entitled Best Practices for Limiting Hazardous Solvent Exposure with SafetyCaps and Waste Containment for HPLC and UHPLC Systems. This is the webinar outline, and I'll be covering these 5 topics in my discussion today. So first, I will provide a short introduction to the product itself and touch on briefly some of the problems that it solves. Next, I'll be providing a review of the dangers of working with hazardous chemicals in chromatography labs. Then I'll discuss each solution individually for the mobile phase bottles, followed by the waste container solutions. Lastly, I'll provide 2 case studies, one conducted by an independent institute to show off the effectiveness of the MacMod SafetyCaps, and the other case study to show the customizability of the MacMod Safety Waste Caps as applied to a real-world analyst's unique problem. So there's various reasons why scientists may want to switch to a safety cap or safety waste cap. And on this slide, you find an example of something I've run into often when visiting analysts at laboratories. This is not ideal for a number of reasons. In this picture, you see various materials being used for solvent reservoir closure, including aluminum foil, parafilm, or drilled holes in the standard bottle cap. And this leads to a variety of issues, including terrible smells, unreliable retention, lab personnel risks, and even OSHA concerns or other regulatory agency concerns as well. So all of these options allow for excess evaporation of your solvents, and we aim to solve that problem with the MacMod SafetyCaps solution. So the first question is, what is a MacMod safety cap or safety waste cap? And this picture shows a standard HPLC stack equipped with MacMod safety caps and safety waste cap solutions for the mobile phase reservoirs as well as waste containers. The difference that the MacMod safety cap and safety waste cap make is that they provide a closed system and with the ability to limit the evaporation of harmful solvents into the laboratory. So this is a picture of where the safety caps are made and manufactured. It's called the Safety Center for Analytical Technologies, or SCAP facility, based in Kelsterbach, Germany. Founded in 1998 and known throughout the world for commercializing the first hermetically sealed mobile phase closure system, so the caps. And these products are now distributed by MacMod Analytical in North America and are called MacMod Safety Caps and Safety Waste Caps. So MacMod Analytical is the company that I represent. So a little bit about us. We have a long history in chromatography. We've become a trusted provider of chromatography products for over 30 years. We started as the exclusive supplier of Zorbax products. Currently, MacMod is the exclusive U.S. distributor for a number of chromatography products, including ACE, Prontosil, and Halo, amongst a host of other HPLC and UHPLC columns and accessories. We provide multiple services, including the ability to solve complicated chromatography problems like making the right column recommendations for specific HPLC or UHPLC separation, providing technical support, or in the case of the safety caps and safety waste cap products, making sure that we work together to find the best set of customized product solutions for your individual safety goals and challenges inside the laboratory. So now that you understand a bit more about the MacMod safety solutions, it's important to understand why the problem of evaporation of solvents into the lab is such a concern. In the next few slides, we'll talk more about the most common solvents used in the lab today and why you might want to consider additional protection against them. So these are the most common organic solvents used in the lab today. I just broke them down by both reversed phase and normal phase LC. You can see the most common solvents used are acetonitrile and methanol for reversed phase. And for normal phase, you can see a couple of weak solvents, including hexane and heptane, as well as other polar solvent modifiers, including IPA or ethyl acetate. As you know, many of the solvents used for reverse phase and normal phase are very volatile, as witnessed here by the low boiling points and high vapor pressures, even at room temperature. And the volatility leads to a loss of solvent into the laboratory air, which puts toxic vapors into the environment and also causes changes in premixed mobile phases and gradient endpoints. The globally harmonized system of classification or the acronym GHS, is a uniform system for classification of chemicals used widely in the chemical handling industry. It provides users and handlers of chemicals the information they need to properly deal with possibly harmful chemicals. And in this case, all I did was pull out two of the most common solvents for HPLC and UHPLC from a table that the GHS provides. As you can see, both acetonitrile and methanol are classified as either harmful if inhaled or toxic if inhaled. And this is of critical concern, especially in today's environment during a global pandemic where safety is paramount. And the health of the scientists in the lab making our life-saving medicines or performing a number of analytical chemistry functions in today's economy is of crucial importance. So now that you have an idea of why the MACMOD safety cap might be necessary to protect yourself against these harmful solvent vapors, in the following few slides, we'll dive into how the MACMOD safety caps actually work to limit evaporation and why you might want to consider them in your own lab. So this is an example of a before and after of the MACMOD solvent bottle safety cap solution. As you can see here, the setup on the left is a serious safety issue for employees. Unfortunately, it's something that I encounter fairly often when visiting labs. This is not only an environmental and safety issue for laboratory personnel. It can also cause a variety of issues, including quality issues with regards to HPLC separations, like drifting retention times, and even solvent losses, which can mean lost money as well. On the right half of the slide is shown the MACMOD safety cap solution, which provides a hermetically sealed cap, fittings for the tubing so that no solvent will evaporate through the loose fit of drilled holes in the cap, and a check valve that produces a one-way air transfer to ensure that the mobile phase reservoir is not under vacuum when solvent is being withdrawn by the pump. In addition, you avoid harmful vapors, the safety caps are easy to change, and we have multiple thread sizes available for any bottle that you might have. So here we have a diagram of the MACMOD safety cap, and it's made up of the screw cap, the PTFE body, the air valve, and the PFA fitting. So in this example, air is being exchanged from outside the mobile phase bottle through the PTFE filter inside the air valve. But due to the valve membrane, which acts as a one-way check valve, it doesn't allow for solvent to evaporate out of the mobile phase bottle. The PTFE filter also holds back particulates in the atmosphere that may exist in your lab. So the contamination of the mobile phase is eliminated. So with the MACMOD safety cap, you'll find 100% hermetic seal so that no solvent is evaporated through any openings or leaks, a freely rotatable cap that won't tangle or twist the tubes that are installed when switching solvent reservoirs, and perfluoroalkoxy or PFA fittings, which are also chemically resistant. So here we see exactly how the air valve works, which is the magic of the safety cap in general. The dust particles and contaminants are held back with the PTFE filter shown in gray, eliminating eluent contamination. The valve membrane then opens to allow air to flow into the bottle to avoid a vacuum buildup and closes to block vapors from exiting. For best performance, it's recommended that the filter be changed every 6 months. We have had a redesign of these products since the image was produced. So all the filters at this point are red filters, which we'll show on the following slide. In the redesign of the caps, MACMOD Safety Caps version 2.0, the focus was put on creating all caps to be fire resistant, more durable since the polymer that makes up the screw cap itself was changed from polypropylene to polyphenylene sulfide, which makes it a lot harder to break. And convenience of the insertion label to mark the solvent line, which is that little white note card on the cap itself. You can mark A, B, C, or D solvent line that you're pulling solvent from. And the lure lock adapter, which is very convenient if you wanted to connect a syringe filter filled with silica gel for extra protection against contamination. We sell both the caps individually or as kits presented here. The kits come with all of the necessary accessories as well to get up and running, including the fittings, blind plugs, and air valves, which are the red filters connected to the top of the cap that you'll need. In the standard kit S1 to the left, 3 of the bottles come with the ability to have 1 line of tubing, and 1 comes with the ability to have 2 lines of tubing. And the second line is intended for either needle wash or seal wash. And then the second kit, which is on the right, has all 4 caps with the ability to have 2 tubes for both your solvent line and needle wash or seal wash lines as per your preference. Generally, people pick this option for the flexibility of being able to use any of their caps in any arrangement they see fit, but both options make sense, and it comes down to mostly preference. The main advantages for the safety caps are that they prevent solvent vapors from the bottles evaporating into the laboratory environment and in turn being breathed in by laboratory personnel. They also prevent particulates from entering the solvent bottles. In addition, they ensure you don't see retention time shifts due to evaporation of solvents in either gradient or isocratic mobile phases. The standard size for glass mobile phase bottles in North America is GL45, and that's the platform that the MacMod safety caps were built on. However, we do provide other sizes as well, depending upon your laboratory's need. In fact, a popular size alternative is GL38, which is meant for the taller amber-colored bottles that both Fisher or Sigma Aldrich provide, which have skinnier necks and are used from time to time for needle washes or seal washes. We also provide caps with even more holes for more tubing if needed, all the way up to 6. I think the most important advantage is that during these very uncertain times with the pandemic, scientists can walk into their place of work and feel safe. They feel like they're working for a company that's invested in their safety, and with all the other safety protocols we have now been accustomed to, including masks, gloves, and social distance, this can be a really effective way of ensuring scientists are minimizing their exposure to harmful and toxic vapors that they work with in the laboratory. So before coming up with a recommendation for MacMod safety caps, we generally need to gather some information from the analyst first. So these are things you might want to think about. 1, how many bottles need a MacMod safety cap? How many tubes are needed for each bottle? What exact outer diameter do the tubes have? From time to time, with the needle wash or seal wash, the tubing can be smaller, and we provide fittings for that as well that are smaller to give a tighter fit. However, for most tubing, the size is 3.2 millimeters, and the proper fittings will come with the purchase of your cap or kit. We also provide fittings separately in packs of 10 or 50 or what have you as well. And what thread size do the bottles have is another question. Generally, the bottle cap, as I said before, is GL45, but there is other thread sizes available too. So we'll now move on to the waste solvent containment portion of the MacMod SafetyCaps solution. So this is an example of a before and after of the MacMod Safety Waste Cap solution. Here you can see a classic example of something I run into. It's also an ineffective attempt at trying to control evaporation, and it lends itself, just like with the safety caps, to vapor emission and safety concerns like spilling, adverse reactions, or fire hazards. As well, if you're using radio-labeled chemicals, you'll certainly be exposed to that as well in the air. There's also the threat of safety inspectors not approving your lab and having to shut down operations until you find a solution, so that could be lost productivity as well. On the right, we have the MacMod Safety Waste Cap solution, which provides a cap that fits virtually to any container. We still not encountered a problem that we couldn't find a solution to with a cap. In addition, we also have the add-on funnel shown here, which is really important to making sure that if you're pouring residual solvent into your waste container, you're really minimizing the spillage. Here you can see exactly how the waste cap functions inside. The waste filter contains a multi-component granular mixture of a highly activated carbon with a very high surface area of 1,200 meters squared per gram. The high surface area combined with the highly activated carbon is what allows for the trapping of the vapors inside the filter. The recommended amount of time before changing the filters is about 6 months with both the safety cap air valve as well as these waste cap filters as well. As mentioned earlier, we have the widest range of waste cap enclosures to fit almost any container. The exhaust filter equalizes the pressure in both directions, inward and outward, to avoid overpressure or underpressure inside the container. There are multiple premium add-ons, like the one presented here, which controls overfilling. As you can see inside that plastic cage, there's a red indicator that will come up when the solvent bottle is near full, and it gives the analyst time to change the waste container before having an issue of overfilling. The MacMod safety waste caps are flexible enough to suit any configuration of tubing that might be needed for your waste container. And as you can see above, we have many different adapters that are suitable for a variety of different situations you may encounter. As I said before, there are questions you might want to consider with your safety waste caps as you would with your safety caps. Very similar questions, but how many tubes per bottle are needed? It's very common to have multiple instruments flow into one waste container, so it may be necessary to implement an adapter, like I showed before, to allow for more tubes. What outer diameter do the tubes have coming from your instrument? We need to provide the right fittings so that the fit for the tubing ensures no air gets in or out through the openings in the fittings. And there's all sorts of different tubing that can be used to go into a waste container, so that is vital. Do you want to purchase a cap for your container itself? If you can't, we haven't had much issues with trying to find a cap for each container, but if your container is unfittable, you might want to consider purchasing a new container. And there are many waste containers available that we provide instead of your current container, and we have a whole line of caps to fit the containers that we provide as well. The final thing is, what thread size do the waste containers have? If you don't know, don't worry. We can use a caliper to measure it and prescribe a step-by-step solution to find the right cap for your waste containment system. So just to review, the MacMod Safety Waste Caps advantages are that they provide an optimized solution to the problem of solvent evaporation from the waste containers in your lab. This works to protect lab personnel health. They're completely customizable, so you can have multiple tubes from different sources coming in, including needle wash, pump seal wash, LC effluent, and from more than one instrument if needed. The waste caps are made of high-quality material with a PTFE body and chemically resistant PFA fittings. The filter, which contains activated carbon with a high surface area of 1,200 meters squared per gram, is really the optimal thing for trapping the most commonly used solvents in your laboratory. So we'll move on to the case studies on the presentation. Here we have case study 1. This was conducted by the SGS Fresenius Institute in Germany. SGS Fresenius is an independent institution that conducted an HPLC separation study to show the loss of organic modifier for 4 different iterations of coverings for solvent bottles. So those 4 iterations are a bottle closed with the MacMod safety cap, a bottle closed with the original cap that comes with your bottle, so just a cap that's closed with no holes. Also a 1-hold cap, so that 1 hole has a 10 millimeters diameter hole, and a 3-hold cap, which each one of those holes has a 3 millimeter diameter. And the samples that were tested were 3 polycyclic aromatic hydrocarbons over a 31-day period through an isocratic separation. So this is the experimental setup, test conditions, and instrumental setup details. As I mentioned earlier, these were the 4 different iterations of each one, so bottle A, B, C, D. The HPLC system used was an Hitachi Lachrome Elite system with a diode array detector. An isocratic pump conditions and premixed mobile phase were used. The mobile phase was an 80-20 mixture, volume by volume, methanol, water, premixed. And the HPLC column used was a C18 5 micron 4.0 by 125. So, as a preliminary step, each of the bottles were placed on the counter for 31 days, and the following weight changes were observed. As expected, bottles A and B did not show any significant changes in their weights, so no solvent vapors escaped from these 2 bottles. In contrast, bottles C and D, the ones with just holes drilled in, showed significant and uncontrolled loss of liquids through evaporation, which you can see from this chart. This is for 1 bottle, so assuming multiple bottles in an entire lab, you can imagine the loss would be significant. So this is the retention time changes we found, or that the SGS Fresenius Institute found from the bottle with 1 hole. So the test clearly revealed that unless you're using a closed solvent delivery system like the ones guaranteed by the MacMod safety caps, as you can see here, unreliable retention times may be encountered even after a relatively short time. After 31 days, the separation of the 3 pHs were repeated under identical HPLC conditions, same HPLC system, in column, etc., using the liquids from the bottles that had holes in them, and the result was a significant prolongation of all retention times of the test compounds, which would make compound identification based on retention times nearly impossible. So the retention times here are shown in minutes, and as you can see, there's significant changes in retention for each of the compounds tested, all the way up from 27% change to 66% change for each of the compounds' retention times. So that's significant. And then that was for the one whole cap with 10 millimeters diameter. Then we see the retention time changes from bottle D, which is the cap that has 3 holes, each with 3 millimeters in diameter. And as mentioned with the other cap that had holes in it, the percent change in retention times for each of the compounds is significant. Another experiment was done to check the methanol and acetonitrile emissions from the bottle with no cap. So this is a different experiment, a bottle with no cap versus a bottle with safety cap in a test chamber with air exchange. So this is completely open to the environment versus the bottle with the safety cap, not drilled holes in this case. And here we see a comparison between 2 bottles inside a test chamber with air exchange filled with acetonitrile and methanol, and a bottle filled with the same 2 solvents and covered with the MACMOD safety caps. You notice that the values of both solvents emissions are considerable, as seen by the graph, after 1 day, and remain steady over the course of 7 days. So there's really high emissions going on here. So this is a bar graph representation to show that in green, you have the emissions from the bottles of methanol and acetonitrile recorded with the safety cap, and in blue, the emissions from the bottles of methanol and acetonitrile with the safety cap. So as you can see here, not putting on a MACMOD safety cap results in 600 to 800 times more emissions over the course of 7 days, depending on the solvent. In these bubbles, I noted that the German Federal Institute for Occupational Safety and Health states that a dangerous level of acetonitrile is greater than 17 milligrams per meter cubed, and for methanol, 270 milligrams per meter cubed, and these way outdo those. So in the second case study, I visited a laboratory that had a very unique problem. And in the picture, you see a container that is very prevalent across one of the largest agricultural and industrial companies in the world. I've also seen it at a number of other labs as well, very popular. It was a company-wide regulation that after filling their waste container with waste from HPLCs, the containers were to become incinerated. This container was the only one that was compatible with their incinerator, and there were already way too many procedures in place to make a procedure change to a different container. And we didn't have an existing cap that we offered currently to fit right onto the container without popping off. So we had to talk with our manufacturers and come up with a customized solution. So in order to solve this problem, we had to take a holistic approach. Because the container was unadaptable and had a unique closure, we used the existing cap to construct a new customized waste cap that looked and felt similar to a MACMOD safety waste cap. This was the only way to ensure that the cap stayed tight on the waste container lid where the seal takes place. The scientist was thrilled with the solution and has since ordered waste caps for the entire lab. We expect this solution to be implemented across the entire company. So essentially what they did here was they took the scientist's original cap and drilled out a hole so that we could put the Safety Center for Analytical Technologies PTFE body in it and close it, and then we have all the other functionality of the original safety caps from GAP. So just like any other MacMod safety waste cap, we provide additional accessories like the ones shown in the picture with a 3-way adapter and an activated carbon solvent filter with a charge indicator to show the elapsed service life. The 3-way adapter shown in the picture has the ability to accept Pygon tubing from the wasteline feeds of their HPLCs and purge valves. And this serves as a customized solution business case for all future problems like this that people deal with regularly. As I mentioned periodically throughout the presentation, we have an extremely wide breadth of technology here that can solve most solvent evaporation problems. These are just some of the additional accessories that we provide. On the left, we have the Verner, which is great for purging or priming the solvent lines. On the top right, we have my favorite solution for quickly connecting or disconnecting tubing to the LC, which is called CPC Quick Disconnect Couplings. This makes it really easy to add new solvents for HPLC separations. And on the bottom right, we also have solvent funnels meant for pouring additional solvent, as I mentioned before, into waste containers when you want to avoid spilling and don't want to have to unscrew the cap. And these can be taken off and put on the cap at any time, so they're really, really versatile. We even sell containers of all shapes and sizes, like the ones presented here, with collection trays for spilling, canisters that are UN approved for transport of hazardous goods on roads and plant premises, and canisters that protect against electric shocking, fluorinated canisters, and even integrated floaters for level control. So in conclusion, solvent evaporation in the laboratory from waste containers and solvent reservoirs is a major issue and pretty much an unsolved problem in many labs today. MacMod safety caps and safety waste caps are effective, customizable, and versatile solutions to eliminate or limit solvent evaporation exposure in the lab. By limiting solvent evaporation exposure, analysts can really ensure that their labs are safer, more cost efficient, and more reliable as it relates to chromatography. So, thank you for listening today. I hope that this presentation was useful and it has made you think more about how to improve the safety in your lab. And I'm happy to answer any questions. So now I will pass it back to Melissa.
Well, thank you so much, Edward. That was an excellent presentation. And as you just mentioned, we are going to open it up for questions. I do have 2 poll questions for the audience that we're going to get to first. But in the meantime, if anybody does have any questions, I just want to remind you that you can type them into the Q&A box on the screen that you have there. So why don't we move on to the poll questions? And I'm going to give everybody some time to answer. The first poll question, and you can answer right on your screen, is would you be interested in learning more about SCAT safety solutions? And I'll give everybody about 20 to 30 seconds to answer. Okay, and let's move on to the next poll question. Do you feel you learned something new about lab safety today? And again, I'll give everybody some time to answer. Okay, now we're going to open it up to the audience questions. And Edward, of course, these are all for you. So the first question that I have for you is, do the caps reduce 100% of the low boiling point solvent evaporation?
So essentially, that's what they're intended for, to be 100% hermetically sealed. As you could see from the, I could go back a little bit. This is an emissions test to show off the reduction in emissions as seen by this blue. So it's not 100%, but it's really minimal as compared to the emissions that could come from, the solvents, acetonitrile and methanol, if they weren't closed at all.
Okay.
I think that's
all right.
Yeah.
Okay. This is another question. It says, are they widely available? And I'm assuming they're referring to as the safety caps. So we'll say, are the safety caps widely available?
Widely available. So, they are definitely available all around the world. The Safety Center for Analytical Technologies has distributors in many, many, many countries. In North America, we are the distributor, so we can provide all of the options on our side, but they do have the availability to do this worldwide as well. So if that's what you mean, widely available, yes, for sure. They have a distributor network that can provide products worldwide.
Okay, all right. Moving on, here's an additional question. Are there replaceable parts for the safety caps that need to be replaced every 6 months like there are for the safety waste caps?
Yes. So I'll go back just a minute to introduce that. Yeah, as you can see here, this red filter is the part for the waste cap that you'll need to replace every 6 months. That's the only piece that you'll replace. Everything else stays with the container forever. So that's really one of the benefits to the safety container, or the waste caps and the solvent bottles in general, is it's really just a one-time cost. And then after that, the filters and the air valves are cheaper and much easier to replace, and it's just every 6 months you replace those. The other stuff is really just a one-time cost, and they're so durable, they really never crack or anything like that. So, yeah.
Okay. All right. Here's a couple-part question, so I'll start with the first one. How do we protect ourselves from rinse solution and rinse reservoir?
We protect ourselves from rinse solution and rinse reservoir.
Yes.
So, I'm not sure exactly what that question is asking, but we do have other closures. I haven't mentioned it in this presentation, but we do have other closures that could be meant for even not just waste containers or solvent bottles. We have things for graduated cylinders, a bunch of other stuff as well. I probably need a little more clarification on what that means,
okay.
But
okay.
We do have other things.
Okay. And maybe the individual may want to reach out to you, or you guys could reach out to them offline. And the additional part to that is, what is the temperature and humidity of the room during the case study?
Room temperature was a normal room temperature.
Okay.
So, yeah, it wasn't like a high temperature. It was a normal room temperature that was observed. So, yeah, I could understand if it was more higher temperature, it would be more emission or whatnot, but they did it at normal room temperature.
Okay. In the second study, were the concentrations reported normalized for the collection time? To compare to OSHA PLEs, you need to calculate an 8-hour TWA.
I'm sorry, can you read that question one more time?
So I think that what the individual is stating is his question, and then in another statement. So, all right. In the second study, were the concentrations reported normalized for the collection time? And then he goes on to say, to compare to OSHA PLEs, you need to calculate an 8-hour TWA.
Oh, I see. I will have to dig into that study further and figure out exactly what the collection time was as it relates to the emissions. I could respond back as I dig in further, but that was just the information I put on the slide, so I'd have to get back to you.
Okay. And then his follow-up question is, we use empty chemical waste bottles. Do you have caps that fit standard 2.5-liter chemical bottles?
Yes. We have caps that fit almost any container. So I'm sure that we have a cap that would fit that container as well. So yeah, I would just have to see the container or conference with me back and forth to get a measurement of the container itself. But we have caps that fit. I mean, I've been in lots of different labs and seen a ton of different containers, and we have caps that fit almost every single one. So I'm sure
that's actually very impressive.
Yeah.
Yeah, very impressive.
Thank you.
Another question, does the lifetime of the red part of waste cap depend on the type of the solvent used with the HPLC?
So, right. This was done under the worst conditions. They recommend 6 months. So it's one of those things that it's recommended to change after 6 months because they did it under the worst possible solvent conditions. But again, it's just the recommended amount of time. The container isn't going to blow up if you don't change the filter. But it is good practice as the activated carbon inside the filter will be essentially used up by all the vapors that it would contain over the course of 6 months.
Okay. And another question, how quickly can you fill the waste container large without much back pressure?
How quickly can you fill it? Okay. Yeah, you can fill it as quick as you want. There was a slide I mentioned earlier where they talked about the overpressure and underpressure. Let me see if I can. Yeah, let me go back a little bit. So yeah, the exhaust filter equalizes the pressure in both directions, inward and outward, to avoid underpressure or overpressure inside the container. So it doesn't really matter how fast you fill the waste containers. The vapors will still, there's little holes, as you see in the top of this thing, that I think are exhaust filters. So it does work to filter out bad air. It's not going to, yeah.
Okay. And we have time for about just a couple more. Do you have fittings for tubes that are thinner than the traditional 3.2 millimeter size tubing? For the needle washes and seal washes, the tubes tend to be thinner.
Yes, yeah, we do. So we have 1.6 millimeter tubing and 2.3 millimeter tubing. So that would be for sometimes these needle washers. It happens with those the waste container and solvent bottles as well. So we do have fittings that fit any tube, and it is really important to find the right fitting for the right tubing because otherwise you'll have leaks through the loose fit of the loose fit of the tubing inside the fitting.
Right. You certainly don't want that.
Right.
Okay, and this audience member says, I need a cap that has more than one tube going into it. Do you have caps that have multiple holes?
Right, yeah. We have caps that have multiple holes. We have adapters that can provide even more holes. Lots and lots of different options. You know, the ability to pretty much service any type of container or configuration of container you might have. So lots of different options here for multiple holes, multiple adapters, all sorts of things. It really just depends on what you need and how we can work together to kind of find a customized solution to service that.
Okay, great. And this will be our last question of the webinar. I have a bottle that we purchased from Fisher, which we use for needle washes and seal washes. It has a smaller top than my other bottles. My other lids don't fit it on currently. Do you have an adapter or some sort of cap for those types of bottles?
Yeah, so we have both. We have an adapter for, I mentioned it throughout the presentation. It's called the GL38. Yep. We have an adapter, and we have just a cap that fits it. So it's really dependent upon what the analyst wants. So either way, if you wanted to use your own GL45 cap and just use our adapter, that can work. Or if you want to use just our cap that is specially made for that bottle, we can do that as well.
Okay. Well, again, excellent presentation today, Edward. I appreciate it. So that's about all the time that we have. Again, thank you, Edward Faden, for the presentation, and thank you for all the participants for your questions and being a great audience. Be sure to check CNEN or CNEN online for information on the next edition of CNEN webinars. Thank you, On24, for the technology and production services, and a special thank you to MacMod Analytical for the sponsorship that made this interactive webcast possible. For CNEN webinars, I'm Melissa O'Mara. Goodbye.